Please pause the video and take a moment to read this important safety message.
Hey, welcome back everybody. Part 6 here in the KT88 single-ended amplifier build, and as you may remember from part 5, we completed the power supply build. I did get some feedback on a few things, and so we made some corrections in part 5B. Please go watch that, very important to your safety. But we're going to move on beyond the power transformer now. The power supply now, and we're going to move into the actual amplifier. And if you'll notice here, the way that this kind of works left to right here is you feed in over here on an RCA input. You come through this audio pot here. There really is nothing more than a voltage divider circuit here to take some of this to ground and send the rest of it to the tube, or to send it all to the tube, or if you want to turn the volume down, turn it, send it all to ground. So you're just determining how much of the signal coming in makes it over here to the first tube here. And then this tube amplifies the signal, kind of sends it along over here into the KT88. The KT88 then has a little bit of what they call shade feedback here that brings the signal back and does some local correction. Coming out of the KT88, then we basically feed over here into the output transformer, and there is a switch here to determine whether you want to go ultralinear or not, and that switch I showed you, we had mounted it in the back of the amplifier here. Then you can take off your 8 ohm load here, typically your speakers. And then what you have left up here at the top is nothing more than where your B plus comes in, which would feed straight to the power transformer, straight to the plate of the KT88. But in this case, takes a little bit of it off, drops it down some, stabilizes a little more with a filter cap here, brings it over through a plate resistor to power the actual driver tube, which in our case is going to be a 6N1P. And nothing really special outside of that, other than you've got a standard kind of bypass cap here on the cathode resistor. But over here on the 6M1P, we're actually going to use an LED or a pair of LEDs to create our bias. And we'll get into this in a lot more detail once we built the amp and we come back and do our walkthrough. I just wanted to kind of give you a general high-level overview of how this circuit is working. And one thing to think about, you've got to build pretty much this entire circuit twice. Okay, and the reason I say pretty much, from here over, you will do everything physically twice. There's 2 output transformers, there's 2 KT88s in the output. Now, this switch here, you're going to be able to share a switch. That's why it's a dual post, dual throw switch. You can use one side for the left channel, another side of the same switch for the right channel here. You are going to duplicate, like I said, everything up in through here. The 6M1P, while you're going to duplicate this tube circuit, physically, this is inside of one vacuum tube. In other words, it's a dual triode, so you will run one side of the tube, one channel through one side of the tube and another channel through the other side of the tube. So while you got 2 virtual circuits here, you could call them, you have one physical tube that they go inside of. And then once you leave that and come back over here, you're back into basically duplicating. The audio pod is another device that you only use one of, but it has a left channel and a right channel set of connections on it here. And then the RCA inputs, you're going to have 2 of, one for the left channel and one for the right channel. So for the most part, you're building all of this twice as we get into this. And I have to apologize to you. I started making this exact same video, and I got about 5 or 6 minutes, about as far as we are in along now, a little bit further. And I took the video out, took it over, put it on my software. Come to realize I had no volume, and I realized I had forgotten to turn on the switch on this microphone. On this camera, if I don't turn on both the camera and the microphone, I end up with beautiful video and no audio. So Anyways, let me show you what I had done. What I was starting with is I was trying to clean up some of these wires that are just kind of hanging out everywhere in the way. And I said, well, I'm going to start back here by bringing over the output connections, right? Coming out the output on the output of the transformer here. And these things are going to feed directly into the output jacks here. And so you can kind of see what I've done thus far. I came straight out of this transformer and I made the leads just long enough to get up here and feed into the yellow here. We'll go, let me find this, there you go. If you look at this little diagram, this is the diagram from EdCore for this transformer. It will tell you that the common is white and then they'll call the secondary, the output, orange, but in reality it's kind of yellow. Just know we're using the white for common here. But I kind of came out, so the red jack here has got the yellow on it and the white jack here has the black jack has the white on it. And did the same over here. I put a little heat shrink tubing on it right here to kind of just keep it neat and coming up out of there. And then two other things here I will mention. One, if you look at this schematic, there is no global feedback on this amplifier. A lot of amplifier designs will take some feedback off of the output here and feed it all the way back to the input here, and that's typically called global because you're crossing across multiple tube sections to provide your feedback. And this amplifier doesn't have that. If it did, I would have probably taken a little 3-lug terminal strip and mounted it right here on both sides, somewhere along right in here, and I would have brought these speaker jacks to that terminal strip, and then from that terminal strip I would have brought them up into the jacks, and that would have given me a place right here on the terminal strips to have actually mounted not only the wires going back to the input here, but also likely the feedback capacitor and resistor if there were any of those as part of the circuit. So the fact this one doesn't have global feedback, I just went ahead and mounted them straight into the jacks here. And one other thing you will start to see here, the output jack right here, okay? And I want to get this so you can clearly see it right here. And let me zoom in on it a little bit. You can start to see here I've also added a black wire on the ground side of this, and I'm just kind of routing it along the back of the chassis here. And what I'm going to end up doing is bringing it over, and I haven't connected it. Oops, you can't see that. I route it around the back of the chassis and I'm going to bring it over, and I'm going to end up tying it off over here on this little strip, which is going to be kind of the beginning of my star ground. And if you'll notice here on the schematic, it'll actually show you that you have got to ground the common. You don't want to use the chassis here to do that with. You have the potential to create some ground loops in it. So these output jacks here in the back are actually floating. In other words, the insulators that are mounting them keep them from actually being grounded to the chassis right here. The same with these RCA, I call these RCA, these banana jacks and these RCA jacks. Both of them are floating. None of them are grounded to the chassis right here at this point. We're going to bring all grounds back via wires back to this starting point over here. All right, so that's where we are thus far, and we'll kind of take it from here and keep moving forward. Okay, I'm just thinking a little more about the physical layout of things I'm going to be dealing with here. And one of the things I've been scratching my head a little bit with and want to put some thought into is I'm going to have to feed out of this B+ through this dropping resistor, come over here through a filter cap, and then down through the plate resistor here into the 6M1P. And as I started looking at this 33 microfarad at 400 volts, the capacitors I've got that I use for that, I'm going to be using for that, are these 33 microfarad at 450 volts Panasonic capacitors. And these things are pretty large in size, and I got to thinking about, wow, where am I going to mount those at down here relative to this little tube here? So I've came to the conclusion that I want to mount another terminal strip somewhere along right in here, and that way I can kind of put these filter caps off of both sides of it here. And so that's what we're going to do. I've marked off 2 places here on my chassis, and I'm going to go drill a couple holes and come back and mount that. Okay, a couple things I wanted to show you here. You'll notice I round the black wire over. I brought it over, bent the corner, came straight up here, and I brought it into this lug right here. And at this point in time, I have not soldered it. I just brought it here and I bent it over. The reason being, I'm going to want to bring a couple wires through this terminal and bend them over and then solder them all at once. The second thing I want to point out, I brought a wire all the way from this back to here. I'm going to want to bring this one all the way over and back to here. What you don't want to get into is daisy chaining. So you don't want to bring this ground over to this point and then bring it back over here. I'm running wires from each point back to my beginning of the star ground here. Now on these RCA input jacks, a little bit different story there. We are actually going to take these the grounding from these jacks over here, and we're going to ground it at the same place here on the well, you can't see that, can you? I'm going to bring the grounds from it over here, tie them to the input tubes, and then from there we will kind of ground and bring it back over here and tie it off. It's about kind of keeping the ground from the inputs tied local here to this tube. So, okay, as it comes to wiring up your amplifier, it doesn't really matter where you start, as long as you start somewhere and work consistently and mark your way off as you go. Pot, I don't know if you can see it or not, but I made a decision to turn my pot sideways so that the pins are facing over here, and that's because I'm going to bring around over here and avoid coming through any of the high voltage sections, my input connections. And so as I'm starting to think about the input connections, you know, I know one of the things I noticed, I got to come out of the RCA input into kind of the pot, and I got to come out of the other side of the pot into ground, and I'm going to want to keep the ground local over here near the pot. So in other words, we're going to establish a new star point somewhere here, and we're going to bring everything from the inputs here as well as this potentiometer, as well as where we're going to ground the input jacks. We're going to want to bring all that to a common point. So I've been thinking a little bit about where do I make that common point, and I've yet to decide that. But in the meantime, I've also been putting a little bit of thought here into this tube. And if you'll notice, one of the things you'll need to do here, a lot of schematics don't have pin numbers labeled on them. They're kind of implied, and they assume that you're going to go look up, like in this case, a KT88, and you're going to realize which pin is the plate, which is the grid, which is the screen, which is the cathode. And so I went ahead and I pulled up a diagram here of the 9AJ pinout, which is what the 6N1P utilizes. It is very similar to the 9A pinout that the 12AX7, 12AT7, 12AU7 series uses, but it has some slight differences. The 9AJ is shared between the 6M1P, 6DJ8, as well as some other tubes that I listed here you could swap in and out. So I just went ahead and kind of made this diagram, or printed out this diagram, and then I just started saying, okay, here the anode for tube number 1, and it tells you that is going to be pin number 1. So I went ahead and labeled everything on the left-hand side here for, everything on the left-hand side for tube 1. So you've got the plate or anode at pin 1, you've got the grid here at pin 2, and you've got the cathode at pin 3. And I went ahead and then and labeled tube 2, the other half of this tube. So you got pin 6 here for the plate, 7 for the grid, and 8 here for the cathode. And one last thing on the 9AJ pinout, pin 9, unlike the 9A, is actually a shield between the two anodes in this tube. And you can take this to ground, which I think we're going to do. It and just the kind of the studying I've done says that this is a lot more applicable at RF frequencies than it is at audio frequencies, but a lot of people still recommend to ground this, so we're going to go ahead and do that as well. So I'm going to have to pick a ground spot over here. Okay, I think I've decided that I'm going to make this point right here my ground. And the reason being, I'm going to wire these capacitors for the filter supply up on this strip, and there's a place that I've got to ground that. So that would be a convenient place for that. I'm also going to bring the output jacks around. That would be a convenient place for that, as well as it would be a convenient place for grounding like pin 9 of this tube. So I kind of like this spot right here. We're going to go with it. So how am I going to make that my new ground bus point? I'm going to take a wire, black wire from here, and I'm going to run it over, out and around, over, and I'm going to tie it in over here at the same point, and I'll establish a new star point here. In this case, we're probably going to end up with just these 2 star points in this amplifier. Okay, as you can see, I've ran a wire from the bottom hole over here on this terminal strip over. I ran it into this lug right here. Remember, I've got all of these except for this very end one here, all tied together via a piece of bus bar. And I've put this one in here, but I've not soldered it because I want to be able to run more wires through there than one. Same here, I came off of pin number 9 here of this tube. A little short jumper over to here, and I've ran it through, and as you've noticed, I've not soldered it. I'll run more wires through that hole before I put my solder on it. Okay, the more I've been plotting this out, the more I have decided I want to go ahead and mount these capacitors and finish out this power. I kind of consider all this up here part of the power supply to some degree. I want to go ahead and get it mounted because these capacitors have a decent size to them. And then that way, once I've got all my components mounted, then it's a matter of just wires running and resistors at that point for the most part, and a couple of LEDs. So what I've started doing is, you can see I haven't mounted these, but I'll end up mounting these up here into this. And what I've been wiring thus far is I went ahead and ran pin 9 to ground, and I'm going ahead and connecting these 39K resistors. So I basically ran from here on pin 1 over to this lead, and from here on pin 6 over here to this lead, and then I'll be able to tag from that lead to this positive right here, and I'll be able to tag from here to here, and then I'm going to have to feed this negative over with a ground wire over to here, and I'll have to tie these 2 in with this ground. And then I'm going to put the 2 4.7K ohm resistors here. I'll bring the B plus around and over. I'll show you when I get it done. Okay, one thing I will tell you is just take your time. Cut your wires, route them how you want them. Don't get in a hurry. This stuff, sometimes I'll spend 10 minutes trying to get one wire the way I want it. And then getting the proper bends on it, getting resistors bent the way you want them. It's, I don't know, it's kind of an art, and it's kind of fun, and it's very therapeutic and relaxing for me. I've seen much better work than I do, but hey, I'm having fun at it, so that's really all that matters. Okay, another little tip I'll throw your way. I'm getting ready to pull out these 4.7K ohm resistors that I ordered that'll go here between the B plus and the first side of this filter cap. But the amp calls for 4.7s. If you will notice, I ordered 4 of them. Personally, I always order a couple spares for anything I'm doing, just because you may cut a lead too short and then it not fit, and you're like, oh gosh. Or it's possible that you end up wiring something wrong and burn up a component when you first turn the amp on. So, if I'm ordering 2 of something, I'll order 2 extras. If I'm ordering, 4 of something, I'll still order 2 extras. I don't always double my order, but just a thought. The other thing, I use a lot of straight angle edges of pliers and whatnot to bend leads with, so that when you get done, you end up with nice sharp 90-degree bends on them. Just makes things look good. Not sure if you can see this or not, but I've done it here and I'm doing it here as well. It just takes a little more time there again. But I always bend my leads so that I can read component values when at all possible here, once they're mounted into the amp. Okay, I've pretty much got this wired in now. I've got the 233 microfarads here. I've got the negative side on over here, and if you'll notice, I've got a black wire then. It's kind of hard to see here. but I have ran a black wire from underneath on this terminal strip over to where the negative is on this terminal strip, and then I'm also feeding that on the other side here via a little wire you can see that feeds it to the very back here. And then I've ran my two 4.7 ohm resistors right here in the middle. And then we've, let's see, what else have we done? We've then ran our wires from the 4.7, the positive side of the capacitor, over here to where the connection point is to feed over to the 39K that's going to go to pins 1 and pin 6, and I did the same over here. So in essence, I've wired from B+, which I've not fed in yet, through the 4.7. I've got the 33 microfarad, then I've got the 39K coming over to two different places, pin 1 and pin 6. And if you'll notice, pin 1 and pin 6 are feeding off of two separate capacitors here. You might could have doubled that up, but I wanted to just try to start separating as much as I could along the way. Now I just need to feed from the center point back over to the B+, and we'll have this whole piece wired up. Okay, continuing on here, we have now ran our B+ from the filter caps over here over, ran it down, and tied it in right here where it'll feed through the 4.7K to this cap and 4.7K to that cap. I've also jumpered these two center sections together right here, as you can probably see here. And so really then both of these middle sections became my B+ join point. And I also have to feed for the input transformer. The red wire is the B+, the blue wire will end up going to plate, and then this white blue will end up going to our switch. So I ran the reds to the B+ over here and tied them off, and I kind of shrunk them with some shrink tubing there. So pretty much got our B+ running over here to this area now, and then we fed between there, here, and here. And I haven't soldered these yet because this is where I'm going to have a few other connections. The shade feedback's going to connect in these points as well right here. Okay, at this point I've taken the two blue wires, which will come over to the plates of the KT88, which are pin 3, and I've ran a blue wire over, and I've used a terminal tag here, same on this side, and then I've ran a wire here from the terminal tag over to pin 3 on both of these tubes. The reason I haven't soldered these ends yet is the same jumper point is where the, it'll actually be this point right here. I'm sorry, this jumper point right here. I'm going to have to tie the shade feedback between this point right here and the 200K resistor over to here. So that's what where I'm tying right now. Okay, I'm tying in the feedback resistor that goes from the plate of pin 3 here on the KT88 over here to the plate of both the 6N1P tubes. So what that's looking like is just coming off of pin 3 here, and I've brought this resistor up, and I'm using, since I'm running a lot of free lead there, I'm running some PTFE tubing, and the easiest way to do this is kind of put your PTFE tubing onto your resistor all the way up to the end, then back it off about how far you think you need for soldering purposes, and then snip it down at the other end, and then you can push it the rest of the way back up on here, and you're good to go solder with at that point. Okay, we've got the two feedback resistors mounted in here now, feeding off pin 3s on each side there. I've also brought the blue wires over here to feed into the same point. And now what we've got to do is we've got to wire in this switch back here. And if you'll notice here on the schematic, we can take a look at it real quick. You've kind of got 3 points to the switch. One side that'll go to the 100 ohm resistor, which will end up going to the screen here on the KT88. We'll have a 1.2 ohm resistor that'll go to the other side of the switch, which will go to the white blue, and then the actual wiper here in the middle will come off of the blue. So what we're going to do to accommodate that is I'm going to take and put two resistors off one side of this that the blue let me think here. The blue-white will go to. So we'll end up feeding the blue-white over here to the ends of these resistors. The center taps will end up coming from the blue here over and feeding into those. And then the other side here of the switch, we're going to have to find our way back down here. Probably bring it from here, tie back into here, and then jump her over to the screens, which will be pin 4 on these KT88 output tubes. So let me do that, and then I'll show you what I've done. Okay, as you can see here, blue and white wire, which is the 43% screen tap, comes out, goes to a 1.2K resistor to one side of the switch. And if I zoom us back out, that's what I've done. I've came blue wire here over. I've came blue wire here over, kind of heat shrink these two together, took them straight into a 1.2K and a 1.2K. See if I can lean this up so you can see it, and fed it into two ends of the switch here, and just kind of heat shrink both ends of those resistors where I soldered them off as well. Okay, we finished wiring up the switch at this point. Remember the two blue wires coming over here feeding through the 1.2Ks to one side. Then I ran a blue and brown wire, one to this jumper right here, and another one over to this jumper right here. And then I'm going to have to go between this jumper and pin number 4 here on the tube, and this jumper and pin number 4 on the tube here with the 100 ohm resistor. And then on this very end of the switch down here, I've got a blue and orange wire, one coming to the left side over here, which is the same as the blue plate lead, and the same on the other one. I've got the blue and orange running over here. One thing to pay attention to, please, is very easy to make a mistake on this. When you're running this wire, and the actual blue wire, make sure you get everything on this side of the amp, whether this is the left channel or the right channel, get it all on one side of the switch up here. So everything on this side over here for me is running to the bottom of the switch, and everything over on this side is running here on the top of the switch for me. You don't want to mix up feedback going from, say, the left channel to the right channel inside of this little switch here. Alright, as you can see, I wired in the 100 ohm resistor here to pin 4 and the 100 ohm resistor here to pin 4 that ultimately feed over to the center of the switch here on the back. So what I've been doing now is just as I go along, I use my little red Sharpie here, and I mark these things off as every connection that I make along the way here. And so as you can see, we've completed a large majority of it thus far. We've really just got the cathode here on this tube, the coupling between these two tubes, and then wiring up the front end and the RCA inputs. I think we're about halfway through on this amp as far as wiring it up right now. Tell you what I'm going to do. I'm going to stop right here and call this a wrap for episode 6, just to keep this from getting too long. And for those of you following along, I don't know if how many of you are building it in parallel or just learning from this or what, but well, hopefully tomorrow we'll get to part 7 then. I will say a couple things. One, the way I'm wiring things here, it's one of 100,000 ways to wire this amplifier. It just happens to be the way I like to lay it out. Other people might take a very different approach. And so, you know, whatever ends up working at the end of the day, you know, just follow some of those guidelines. If you'll notice, I'm keeping these wires here that ultimately feed to the plate and the screen. I'm keeping those a good distance here away from the speaker jacks, and I've kept it all away from the front end here. I'm trying to do my best to keep the power supply and kind of the front end away from each other here. And to keep high voltage wires from crossing low voltage signal wires. Outside of that, and then just twisting heater wires, you know, the rest of it's just a little bit of, you know, however you want to do it. And somebody pointed out to me this morning that I should wire the hot wire here on my switch to this end instead of that end, and so I need to flip these two wires, and I'm going to do that before episode 7. The point they made was you have less chance if you're removing the fuse with it live of getting shocked if this the other wires if these are flipped around. So we're going to do that. Thanks for watching, everybody. We're having a lot of fun here. This is very soothing, very time consuming, but it's kind of like trimming one of those little trees. I can't remember what you call them, but that you sit on your desk. It's therapeutic in nature.